Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by Cachefly at CACHEFLY.com. This is Floss Weekly with Randal Schwartz and Jono Bacon, episode 115 for April 3rd, 2010, the ACM IEEE Super Computing Challenge. It's time for Floss Weekly, the show that covers free, libre, and open source software, and in this case, maybe a little hardware too. Say hello to Jono Bacon, Mr. Ubuntu Community Manager and the author of The Art of Community from
yes, indeed.
O'Reilly.
Good book, available in all good bookshops. Excellent forward. Go and buy it. Enrich your life.
Also, we're so glad to have him back from his hiatus.
Yes.
He took a little time off to work.
Yep.
Which is kind of upside down, but that's good. How's the new job, Randal Schwartz?
Oh, there we go. I was waiting for my name so I could
I didn't
prompt
say
you.
your name. You're right.
For those that are watching the live stream, they actually see that I'm on the 44th floor of the 9th tallest building in downtown LA. And I'm just now on the third week of my new job. I'm allowed to say it's oversea.net, because they're providing the booth space right here, right now, so I can actually chat with you guys and give me a little time off so I can do today's show. And I love it. It's a great job. It's probably 3 months to 6 months long, depending on how bad I screw up towards the end. But it should be great. I'm having a great time. I'm actually writing Perl code, writing template toolkit code, working on architecting very high-performance systems. These are the kinds of systems that get millions of hits a second, because they're doing all sorts of things. If you go to lowfares.com, there's a little chart that allows you to do price balancing and stuff. And that's what they do here. So it's kind of cool. So we're getting to work with really high-performance sites here, which is really a lot of fun for me. And I just want to say, Jono, thank you for taking over the last couple of weeks while I was getting started with a new job, because I didn't want to take any time out on the Wednesday. So really, thank you for holding down the fort for the last couple of weeks.
Problem.
Really appreciate that. I do have a couple of pieces of open source news I just wanted to bring in real quick. There was a decision yesterday on SCO versus Novell. We may finally see the end of this. Maybe, although I've just heard now already they're filing another lawsuit. It's silly. But the jury decided that, yes, indeed, SCO doesn't own any part of Linux or any part of Unix either.
No.
So
I didn't even realize it was still going. I know. I stopped caring about 5 years ago.
More than 5. It seems like it's been going on for 10 years now. It seems like it's been going on forever.
I just wanted to bring that in because it is news that happened in the last couple of days, and I'm sure there's going to be, but it's the trustees of the bankrupted SCO that are still fighting the fight. I can't believe this, that they're like dead carcasses hanging out in the corner. They're saying, but I got a little bit left in me still. I still can sue you a little bit about this. So pretty crazy stuff.
Old man with hot air. Yeah.
And also, one other piece of open source news. I got reelected to the Squeak Smalltalk board for the third year in a row, and I'm really happy about that, because that means I still get to guide and direct how Squeak comes out. And Squeak had its actual license release. It's finally clean. 4.0 is clean. It's per your MIT and MIT and Apache license from top to bottom. So we're really excited about that, because it means that people can use Squeak in a commercial environment without having to worry about how many signatures they need to get to be able to relicense it and reuse it. So we're really happy about both those, and these both happened in the last couple of weeks. So I thought I'd bring that into this show as well.
Great news. Great news. So today we're going to talk a little bit about hardware, which is kind of a departure for us, and in particular a supercomputing challenge from the IEEE ACM. Yep.
We've got Doug Smith on the line, or soon to be on the line, talking to him about the ACM IEEE Supercomputing Challenge. And I believe this involves teams from all over the U.S., maybe all over the world, who are coming together to basically outcompute each other. So they're going to build these clusters, which are combinations of hardware in various shapes and sizes, and run benchmarks and run end-user applications, or computing applications, and try to oust each other and do it over a fairly long period of time. I think it's like 48 hours or something for the conference. That's crazy. But yeah.
Well, let's get him on the line. He's here. Let us go to Colorado. What do you say? And say hello to Doug Smith. Hey, Doug. Welcome to Floss Weekly.
Great to be here.
I'm guessing you're at Colorado University. How would I know?
I don't know. Could be my background.
That big CU behind you. He is the HPC sysadmin for Laboratory for Atmospheric and Space Physics, or LASP, at the University of Colorado, Boulder. And also the faculty sponsor and team coach for the UCall. Do you call it UCall? That's not really kind of, is it really the best? The University of Colorado team in the student cluster competition. What the heck is a student cluster competition?
Well, it's a competition of undergraduate students, which will build a cluster and run it and run real-life scientific applications for a real-time competition that spans about 48 hours. It's held every year at the Super Computing Conference here in North America, which is sponsored by the ACM and the IEEE.
Where's the conference?
That's it in a nutshell.
So where is that conference at?
This year it'll be held in New Orleans, November 13th through the 19th, I believe.
Oh, so it's a rotating conference, goes different places, different times?
Yeah, last year we were in Portland. Year before that, we were in Austin, Texas.
Cool. So how, describe this cluster competition in a nutshell. What are people doing? So is it just for students, or who can participate?
So it's an undergraduate competition. So only undergraduate teams. You can have a team of 4 to 6 undergraduates with. You can have high schools, universities. Really, the only requirement to be a participant on a team is that you have to be a true undergraduate. You have to be enrolled in at least 6 credit hours at a university, and you have to have a lot of passion for this kind of thing. The goal is to sort of train the next generation of HPC enthusiasts, administrators, engineers, so to speak. You can be in any kind of major. Our team in the past has had everything from an economics major to applied math. It's not just electricals and computer science majors.
Now, HPC, that's the high performance computing. What kind of applications would I use high performance computing to solve?
So fluid dynamics, explosions, modeling explosions, any kind of anything where you can break the problem down into chunks and spread it across a lot of CPUs or cores. This year, the applications span from biological sciences. There's an application called NAMD, which is a biomolecular model. Flash code, which is used for modeling a lot of things, magnetics, flows, fluid dynamics. We also run a standard benchmark called the High Performance LinPack, or a suite of benchmarks called the HPCC. So anyone who follows high performance computing and follows what we call the top 500 list, which is a list of all the top 500 supercomputers in the world, they all run that benchmark, the HPCC benchmark. So you can sort of compare apples to apples across hardware platforms and architectures. We'll also... Sorry, go ahead.
Is this kind of akin in many ways to, for example, the whole folding at home thing, where people were putting together these big clusters of computers and they were kind of like competing to who could have the most badass computer in the world, that kind of stuff?
Yeah, there is an element to that, an element of that in this competition. However, we are power limited, so all of the team's computing hardware can only run on 2 13-amp circuits. 120 volt. So right. You're very power constrained.
So your limitation is just electricity.
That's the core limitation. As far as limitations
don't you just put lots more of those 4-way plug things in and just string them all together until you have enough things plugged in? Isn't that how it works?
Yeah, and the conference electricians really like that too.
That's the reason why you're doing what you're doing and I'm not doing what you're doing.
The limitations are basically that you have to be using commercially available hardware as of the start of the competition. You're power constrained. you can only have one rack of equipment, which hasn't really been an issue because you can't power even a full rack on two 13-amp circuits. The software has to be, obviously you have to have a software stack that will build the models. But outside of that, the limitations are few and far between. I mean, we sort of call this internally the Formula One of HPC competitions.
Right. So essentially you can, within the hardware limitations, you can have as flexible of a software stack as possible. Is that right?
Yes.
And in terms of the hardware, is there a lot of variation in hardware? I mean, it sounds quite restrictive in terms of what you can do with hardware.
There's actually quite a bit of a range of hardware, and it goes more to the team's strategy of how they want to solve HPC-type models. The teams are basically asked to run a cluster in the same environment that you would run a data center or a cluster at a national lab. Once the competition starts, I, as the faculty coach or mentor, cannot have any contact with the undergrads. They're on their own. They have to look at the models and look at the data sets and figure out how to get as much of that processing done in the 48-hour time span as is possible. We've dealt with power outages in the past. The teams have dealt with hardware failing. So everything that you see in a modern scientific computing facility or a high-performance computing facility is condensed into a 48-hour period. The teams can modify the source code if they want. However, we've not seen that in the past, mainly because these models are pretty complex. Right.
And when you're working on this, I mean, this is a competition. What can you win? I mean, you said it's the Formula One of that kind of work. Do you spray champagne over each other and with a car or something? I mean, what's up for grabs?
The biggest thing up for grabs for undergrads is job potential. Right. Of course, there's big bragging rights. We don't really. This year, there is talk of there being actual prizes. I don't know what they are yet. In the past, everybody that's been on our team has been opened up to very lucrative career opportunities and internships, and it's a great networking experience for the students. This conference draws upwards of 10,000 attendees.
Wow.
Right. And in my experience, is probably one of the last remaining big conference kind of events.
So with 10,000 attendees, how many teams is that?
In the past, we've varied from 4 to 6 teams. This year, I believe we have space for 8 teams, and there are a lot more proposals being submitted than there are spots for teams. So there is a preliminary elimination.
Mm. And how many people are on a team then? It must be quite a few if you've got 48-hour operations, right?
4 to 6.
Really? Okay.
Yep. So, lots of caffeine and late nights.
Yep.
From an
idiot's perspective, that's my perspective, just in case we were unclear. If you're putting together this team that's going to run the ultra hardcore computing environment that you're talking about for 48 hours, you say you need a lot of caffeine. That infers that you're going to be awake late at night, staring into the wilderness, trying, keeping this thing going. Surely you just kind of build this machine and then just run it, and then you go away for the weekend, come back, and it's done its processing for 2 days. What kind of maintenance do you need when the competition's running?
Well, we're really pushing this hardware pretty hard. Most computing facilities build in a downtime or an 80% threshold where they're not pushing the clusters, the entire machine, as hard for an extended period of time. For instance, our facilities here, we have big peaks and valleys of utilization. where we may run 80, 90% utilized for 3 or 4 weeks, and then we may only be 20 or 30% utilized. We're condensing that type of run schedule into 48 hours. So you may have 10, 15 minutes of downtime, and the rest of the time you're fully utilized. Things tend to fail when you're pushing them that hard. We don't have cooling, so the processors are running, the ambient temperatures are pretty high. Also, the models, you have to understand, we're taking a group of undergrads that don't have the background in the science domains of some of these models. So not only do they have to sort of get up to speed at a very basic level of what the science domain is of a given model, but the models are very complex, and they have to know how to break these models down and distribute them across the cluster. Sometimes you can run multiple jobs, sometimes you can't. Those are all the things that you learn throughout this process in HPC and in this competition, is how to do resource management and really how to push the hardware and schedule it the most efficiently. In the past, like I said, in Reno at the very first year, we had a power outage right in the middle of the competition. Right. The entire convention center lost power. And, the students sort of threw up their hands and, what do I do now?
Well, it probably was a good test to see if people were taking appropriate snapshots during the middle of their run, right? To see if they were writing stuff down the disk from time to time.
Yeah, exactly.
Was anybody avoiding that? Did anybody actually lose everything up to that point?
I can't speak for the other teams. I know that we didn't lose data that we had processed. We were able to pick up a run right where we left off. When the power went out the first year, we actually lost an InfiniBand card, and it took the students several hours to troubleshoot and replace that card. So you lost some valuable processing time.
Yeah, I'm not much of a hardware geek. I'm trying to imagine what this power limitation actually means. And can you put it in terms of, say, how many Pentium machines this would represent in terms of power, or how the disk would be distributed, or whatever?
Well, you couldn't run 4 coffee makers on the amount of power for the amount of time that we're asked to run on. So you think
that's not much,
right?
Wow.
So what are some typical hardware configurations that fall under this guideline?
Well, 96 cores of Intel Nehalem will fit in that power budget. The interesting thing is that during the benchmark, we'll max out the power. We will consume all 13 amps on both circuits, and we'll run as close to the limitation as possible. But then when you start running the applications, you begin to learn that some applications run very efficiently. They don't tax the hard drives, or they don't tax memory, and that really affects the power draw on the clusters. So a typical model, if it's CPU intensive but not I/O intensive, may only be like 8 or 9 amps on our limitation.
Do you rig it up the other way then? Do you kind of go, well, we know it's going to be a little bit easier to run, so we'll run a little bit more of it and tweak it a bit?
Yeah. However, the interesting thing there is you can build the cluster and tune it for the benchmark and grade it and get a great benchmark score, or you can take a hit on the benchmark and do much better on the applications. So depending upon your architecture and the choices you decide to make as a strategy, those things can be very different. The interesting thing is that the HPCC benchmark basically spits out a megaflops or gigaflops or teraflops number. And nobody who has ever gotten the highest on the HPCC benchmark has ever won the overall competition, which tells you that bringing the the biggest, fastest CPUs to the competition may not always be the best strategy.
Wow, sounds like there's a lot of variables here, a lot of things to think about then in trying to design the system. What's the software stack typically look like? What kind of operating systems, what kind of tools and stuff are being used?
Most of it's open source. So we're running, OpenMPI. Yeah, OpenMPI, Linux. We have had 2 teams that have brought Microsoft HPC server to the competition. But the majority of them are Linux, OpenMPI of some flavor, GCC compilers. Occasionally, you'll see the Intel compilers. Just trying to think of, we've run in the past CentOS.
Mm-hmm.
This year, we will probably run Red Hat or Fedora, something along those lines. There are a lot of variables. What kind of InfiniBand you run and things like that. We're also partnered with a hardware vendor in such a way that there are limitations as to the hardware that you can get, right? We're operating on a shoestring budget of 0 or very close to 0. So you find a hardware vendor and you try to haggle with them as to what the best hardware they can give you. And most of the time, the vendors are very forthcoming with hardware because, of course, there is a marketing aspect to this as well.
Now, how much tuning do you do on, say, something like the core operating system for something like HPC? Are they pretty good for the stuff coming out of the box, or do you end up spending a lot of time tweaking that as well as the applications?
The core operating system is usually pretty easy to shut down most of the non-essential things that would impact performance. The majority of the tuning at this level is done in compiler flags, libraries, things like that. This is not a programming competition. You're certainly welcome to modify the source, but that's usually beyond an undergraduate skill level. So mostly everything is, as far as optimization, is scheduling, resource management, as well as compiler flags, I would say, are the big ones.
So it's more about learning to use the tools rather than writing tools from scratch or doing any sort of low-level debugging and things.
Right. We do have, some students, if they can get far enough into the models, they'll do process profiling to find out where the models are spending their time and try to optimize those routines, those libraries. But usually it's at the compiler flag level and choosing libraries that are pre-optimized. For instance, a lot of teams use the Intel compilers on the Intel processors. They'll also use the Intel Math kernel library because it's optimized for that software environment.
You said that you don't have any like special air cooling and stuff, and I imagine even with 36 amps, it's going to be generating quite a bit of heat. Do you have any concerns as you're going to New Orleans that might be a little warm this year for that?
Yeah, I don't know. I don't know what the average temperatures in New Orleans are. I think the humidity would probably have something to do with it as well. You can stand behind these clusters and get pretty warm, and they're pretty noisy.
Oh yeah, cool. So what's been the biggest surprise out of these competitions? So what is there some unusual result that happened, or some unusual combination thing? I mean, what would be unusual?
Unusual. It has been the sort of the situation that the biggest, baddest hardware does not win the competition. That's been historically been the most surprising thing. Other unusual things that have happened is, last year in Portland, we pretty much drained the Portland Convention Center of all Mountain Dew.
It's a risk.
The students really start to lighten up around the second day, and the teams sort of mingle, and some interesting side competitions develop. So, for the past couple of years, people have had these running bets of who can go out and grab the most storage in thumb drives from the vendors on the show floor.
Wow.
We have had some interesting late nights with students sleeping under tables and things like that.
So you get a little weird because you're sleep deprived, obviously. Yes. And what do people do when they're waiting for the next piece of the result? I mean, are they sitting there just staring at the screen, or are they doing role-playing games, or are they have their own laptop set up, they're playing, World of Warcraft against each other or something? What are they doing while they're waiting?
Well, a variety of things. We've had, Xbox. Last year, Arizona State was sponsored by Microsoft and IBM, and they brought an Xbox. So there was some Xbox gaming going on. They also brought a really nice cappuccino machine to keep everybody caffeinated. A lot of times the students are trying to build and optimize as much as possible the applications, even during the runs. So, for instance, you may be running, say, Flash code, and one of your other applications for this year is NAMD. You may be optimizing NAMD while Flash is consuming the whole cluster. The students get pretty hardcore, and they really are motivated to do well at this competition, and they try to squeeze every flop out of the applications.
I gotta giggle. You use the word flop. It's flops. There's no singular
flops.
for it.
Yeah, that's true.
Floating instructions per what? Has to be per second.
Yeah, per second. So, yeah.
That was a gimmick there. Yeah, that's a nit. I know it's a nit, but I catch it every once in a while.
You're not kidding.
I would catch that if my students said it. So
what's the singular of flops?
There isn't, because it's not plural in the first place.
I know.
Yeah, touche. I would call my students on that if they said that. So.
All right.
Okay. All right.
Just smile and nod, Leo, like I'm doing right now.
Yes, of course.
Smile and nod.
That's a good joke. Yes.
Did we cover what the winners get if they win?
Yeah, they get bragging rights and jobs.
Okay, well that's good.
Two good things.
But no money. Do they get to keep their hardware?
No, actually, that's up to the vendor. That's actually up to the vendor. This year, there have been some ideas thrown about what kind of prizes there may be, and teams potentially getting to keep their clusters. The sponsors that we've had in the past, one of them has actually allowed us to keep the competition cluster that we took.
Wow.
These clusters usually range anywhere from 80 to 150K. So they're not insignificant. It's not an insignificant expenditure for a vendor to do that. I mean, especially to a group of undergrads.
Have you had any international competition, international participation on this?
Yes. The first year we had a university from Taiwan, as well as a university of Alberta from Canada, to the extent that that's international.
I'd say Canada's a different country.
Yeah, but they all speak the same language, and they're pretty much just like us.
Yeah.
The team that won in 2008 was from Indiana, Dresden. It was a combination team. So there's a team from Germany there. This year, I've heard rumors that there are interested parties from Ireland and Taiwan and some other places. So
now, what's the competition's in November, but is there a timeline for people signing up for this? If somebody's listening to this show right now, is it too late, or can they actually get involved?
Yeah, the timeline looks like, so the next big important date is April 16th. April 16th is when the preliminary proposals are due for if you're an interested team. So, sorry about that.
That's somebody calling in that wants to be on team.
I'd like to do this. I've got a PlayStation 3 and 26 amps. I'm ready.
I got my amps right here.
I got my amps.
Yeah, sorry about that.
That's all right. So where do we go to find out about how to participate in this?
Well, you can go to the Google search engine and just type in SC10 student cluster competition, and that will send you to the supercomputing website, and you can navigate through there for if you go to technical program and challenges.
This is great. Boy, it looks like so much fun.
Mm-hmm.
Is the chief challenge just the chief's limitation, the amount of power you can use?
That is the main limitation.
It seems such a small amount. Yeah.
Yeah, and actually, sort of back to the timeline. This is for us. This is a year-long event, right? I mean, we start recruiting in January. Recruiting people for our team across the campus. We will submit our preliminary proposal, and the information's on the website about where to submit it and what needs to be in the proposal. The submission deadline is April 16th. Then, the teams that will be invited to compete will be notified, I believe, sometime in May. And then the teams work through the summer with their partner vendors and sort of get everything up and running. Then in September, you'll submit a final proposal, which will outline in detail your cluster solution and performance figures that you're getting and things like that. None of the teams see the other proposals, so nobody knows what the other teams are bringing or even what the other teams are until usually the first day of the competition.
Wow.
So typically a team would arrive on the Saturday that starts the conference, and you would use Saturday and Sunday to sort of set up your cluster, set up your booth, test and tune, and do last-minute tweaking. And then on Monday, you begin to run on metered, what we call metered power, competition limited power, and you run the benchmarks as the first thing. You cannot proceed to the applications until the benchmarks are turned in. And then from Monday night until Wednesday afternoon is when you're doing the heavy lifting of your processing, right? You're running all the models and trying to get through as much of the processing load as possible. Then Wednesday, they'll end the competition. Thursday morning, they will have an interview process where they have a panel of judges which will go around to each team and ask them a series of questions to sort of gauge the amount of knowledge that they've learned in this process and to explain their solutions to the problems and the challenges that they faced. Those judges will turn in scores, and they'll tabulate all the scores from all the different phases and announce a winner Thursday afternoon.
Wow. Now, you said there was a couple of cutoffs in there. You said there's a preliminary round. How many teams make it past that, or is that just a name? The
preliminary proposal, so I believe they have space for 8 teams this year, and I think I've heard that there have been proposals or interest from 15 teams so far.
So it's like a 2-to-1 filter there somewhere. Okay.
Right. So and potentially higher. I mean, we won't know until I guess the competition organizers won't know until April 16th when the deadline passes and they take all of the proposals.
Wow. So you got to have a good written up story about what you say you think you're going to do, and they decide it based on that.
Yeah. They like to see that you're partnered with a hardware vendor, and that you've got the models built and running on some type of hardware. They like to see, a proposal of what hardware you anticipate bringing, and then in September, when you submit a final architectural proposal, you should have more detail as to what you're actually bringing, what the performance numbers are, and things like that.
Fascinating, definitely fascinating. Sounds like I had one other question, which is, do you ever, at the end of the competition, take all the machines and hook them up into a giant supercluster?
No, but we do the next best thing, which is run unlimited. The students, after the competition's over, the students really want to, blow past that 13 amp limit and see what they can do.
They want to see smoke coming out. Yeah.
yeah, exactly.
Somebody made a good point, which was that it also keeps the price down. So in a way, that constraint is a good constraint, because otherwise people would be spending a lot more. Some teams would have so much money they'd outspend the others.
Right. Past vendors have been, IBM and Microsoft and Dell, and Apple has been in it. Asus has been in it. HP's been in it. So there is the potential that without these kind of design limitations, an organization could throw a ton of money at it and sort of game the system.
Wow.
Yeah, I can
Very
see that.
cool.
Yeah. Sounds like fun. I bet Colleen would love to do this.
Yeah, the interesting thing that has come out of sort of this unlimited sidebar competition is that under the power restriction, it's very hard to break a teraflop. And I think everybody is sort of shooting at that target, to try and break a teraflop under the power limitation. The power limitations are the same every year. So you can really get a sense from the benchmarks, the progression of the technology over the past 3-4 years. This competition's only been going 3 years. So unlimited, you can break a teraflop, though.
Of course, obviously, or else they wouldn't be doing that.
Now, wait a minute. Is it a teraflop or a teraflops?
Oh, yep.
Yep. Yeah, you got me again.
Whoopah.
It's not a triceratop. It's a triceratops. All right. I'm sorry. That's just pedantic of me.
That is very pedantic.
Yes.
But hey, I started it. I'm sorry.
Leo, I've watched enough of your shows. I should know this.
That I am a pedant? Well, I'm thrilled that you watched, Doug, because this is the kind of thing that I guess can individuals participate in this? Because it'd be fun to field a TWIT team, or does it have to be a school?
That would be a question for Haya Nam at Oak Ridge. She's the chair of the competition this year.
It's really for schools. I'm sure it's not for.
Yeah, I think it's really designed with the educational aspect in mind. Scientific computing is typically a little bit lacking in a lot of schools' CS curriculum. There might be 1 or 2 classes that you would take as an undergrad that deal with scientific computing, and they're typically pretty difficult, which tends to scare undergrads away from them a little bit. So this is another way. This is a hands-on way to drive enthusiasm in this area.
Is there any live broadcast going on? Are you live streaming this or anything at all while it's going on?
Not yet. We would love to.
Ooh. And I'd love to go to New Orleans in November.
I'm actually going to be there. I just realized that we're going to be there as part of
Are you are you part of this? Are you for like the ACM meetings?
No, I'm there because Linux Fund is going to be represented there because Linux Fund has a lot of stuff to do with supercomputing.
Well, we'll set you up with. We will live stream then. We'll set you up.
Okay,
with
great.
A camera
Yeah,
and you can
I'll
do
be
that.
happy to
That'd be
interview you
really
guys.
fun. Yeah, that'd be
Cool.
really
Yeah,
fun.
that'd be great. Come by our booth.
Mm-hmm.
And we're gonna root for Colorado, blue and gold, blue and gold.
Blue. No, it's black and gold.
Black and gold. Blue and gold's Michigan. Black and gold.
Yeah, I'm wearing one of my sponsors' shirts today. So we, Lockheed Martin has been very generous, to help pay for student expenses and things like that. We usually have to cover our own travel to some extent. There are a whole list of expenses that come along with this. But the key thing to note there is that even in this sort of down economy, this conference has been very successful in maintaining or increasing its attendee populations. So it's a great networking opportunity, a lot of great exposure, a lot of very cutting edge talks and presentations. The students get access to what we call technical program credentials, so they can go to the talks and the panels, and they can go to the exhibit floor and see all the latest and greatest technology.
Great. Very cool. Hey, Doug, it's really been good having you on today. I'm really glad you got a chance to share this, especially in a timely way, so anybody who is thinking about joining, they can still have time to actually sign up for it if they go to the website. So that's really appreciate you coming on today.
Thanks, Doug.
Yeah, and we really appreciate the opportunity.
Cool.
Great to have you. Thank you, guys.
See you in November.
See you
All right.
in New Orleans. Take care, Doug.
Yep, you too.
All righty. sc10.supercomputing.org if you want to know more.
Mm-hmm.
That looks like a lot of fun. I love the challenge of having the limited hardware constraints and making it work. I think that's really fun.
It kind of reminded me of, have you seen the 5K competition?
No, what's that?
It's basically it's a programming competition to see how much you can get into 5K of memory. And someone wrote a JavaScript program to create Wolfenstein 3D in 5K. It's like tiny in a web browser. It's amazing what somebody can do with 5K.
Wow. That's amazing.
Yeah.
Hopefully we see some GPU this year. We've not seen that in this competition, and I'd really like to see if somebody brings a solution with that.
Yeah.
Cool.
Pretty phenomenal stuff.
I think one of the reasons you can get JavaScript in 5K is you can compress it, right?
Yeah.
You don't have to. It's plain text, so you can you can just squish it, squish it way down.
Squish it. Technical term.
Yeah.
So Leo, you've got a hardware show. Is it Ryan Shroud?
Yeah, it's coming up. Ryan Shroud's Twitch. It's coming up in about 45 minutes, as a matter of fact.
Mm-hmm.
Yeah, I would think he would be interested in this because all of the hardware is pretty cutting edge. I mean, these machines would make some great gaming machines.
Yeah, no kidding. Yeah. And do you overclock at all? Are they allowed to overclock?
You can overclock.
It's just there's a power penalty, I guess. Disadvantage. Yeah.
There's a power penalty, and not all of the models will respond well to overclocking.
Right.
So the most of the overclocking that happens is turbo boost. What's provided in the processor.
Right. Right.
Mm-hmm.
All right. Thank you so much, Doug.
Yep. Thank you.
Bye, Doug.
Take care. Doug Smith from the ACM IEEE Challenge.
Mm-hmm.
Challenge, the SC10.
Well, I didn't realize this was tied into the supercomputing conference because when he mentioned Portland, I went, oh, yeah, that's the thing that Linux Fund helped operate with this year in Portland. And we're actually going to cooperate with them in New Orleans in November. So, yeah, I'll be there. I'll be there. Right. So it'll be great. I'll be down there covering it for you guys then, I guess, or us.
I think you will. I think I would really like to cover that. I just love that idea. And it fits very well with our audience because they're very interested in what you could do to soup up your supercomputer.
Yeah, very cool, very cool. So, it was a good guess. So I've got some other good guests coming up. You want to hear about those, Leo?
Please go right ahead, Mr.
Okay.
Schwartz.
I have coming up next week, I'll be back home with my big blue Yeti again, not on the road like I am today, but I'm going to talk to James Snyder. He has the Embedded Lua, eLua project. And Lua is the programming language that is embedded in a lot of applications like Lightroom and World of Warcraft and things like that. But he's got a version of it that is working standalone in small microcontrollers. So you'll be able to use it like we had the processing language, a couple of languages that were designed to be in small equipment. eLua is in that category. So we'll be talking to him about that. And Jono, I don't know anything about Codeplex. Do you want to tell me what Sam Ramji is going to talk about?
Yeah. So the following week, we're going to have Sam Ramji on the blower, and Sam used to work at Microsoft. He was their kind of their open source project leader, essentially. So he was. A lot of people viewed him, and there used to be a guy that worked there called Bill Hilf, and he was kind of like the new Bill Hilf, who was the open source community's representative at Microsoft. So he was something of a controversial figure for people who hate Microsoft, obviously. But he's a great guy. He's since left Microsoft, and he's worked on the Codeplex Foundation. So I think it's going to be a really, really interesting interview. So I'm looking forward
Absolutely.
to it.
Sounds good. And following that, we've got me back again talking to Sean Pierce, who has come up with a version of Git called Garrett that's being used on the Android project, and it has a built-in bug tracker and bug sign-off system, migration system, and so on. So that's going to be pretty good. But the show I'm really looking forward to, not that I'm not looking forward to the other ones, is the following week after that, we've got Scott Maxwell and Paolo Baluta, who are the Mars rover drivers. That's their job. Wow. They get to drive the rover. It's funny, too, because I'm actually going to be just down the street from them. JPL is just up the street from where I'm working here. And so we'll still be Skyping in, but it'll be like they'll be just right over there. Maybe I'll actually just go up to JPL that day. That'd be kind of cool. But they're going to talk to us about all the work that they do, all the open source that they use, and actually why some parts of it are not open source and how they have to get around that and stuff. So it's pretty interesting stuff. And I'm really happy to have gotten this interview with these guys. Matt Ray of Xenos is coming up. That's a network and server monitoring package. And then just added to the schedule, this one sort of is one of these ones where people write me and it just happens, which is really nice. Jonathan Simpson, who works for the PDPC. I forget what the letters actually stand for, but they're the guys that run the Freenode, IRC networks, Geeknik, a new conference is going on, FOSSCon, another conference is going on. So this is infrastructure guys, people that are supporting open source by putting their time and effort into providing all these infrastructure services. So I'm really happy to have Jonathan Simpson on coming up on the schedule, on the short list. If you want to see the rest of the list, go to twit.tv/floss. There's a link there to my spreadsheet that tells about all the upcoming guests I'm working on. If you want somebody added to that list, please have them write me, and they will go right to the top of the list. And that's how people get added. You can follow me on Twitter at twitter.com/Merlin. And if you follow me, you'll notice that in another couple of weeks, I'll be at the Texas Linux Fest, the first year that's been happening on. I'm a keynote speaker there. And Infotech 2010 is happening 2 days later. So you can follow me all my escapades as I travel through the Midwest. So please follow me and join in. And I'm also doing tweet ups as I'm going in various places. So if you want to find a place that I'm hanging out for happy hour or something, please just follow me on Twitter and you'll get the information about that.
Well, as long as we're plugging, let me plug Jono Bacon, who is the
author of The Art of Community, a great book with a wonderful foreword.
Wonderful
foreword available at bookstores everywhere. And you can follow Jono on Twitter. He's JONOBACON.
Yes, indeed. I've actually one plug, which I'd like to do on behalf of some lovely people, if you don't mind.
It's funny because those computers only have one plug, too, so it's perfect.
Waka, waka, waka.
Waka, waka.
Some time ago, we had Paul Davis from the Ardor project. That's a digital audio workstation for open source systems. It's kind of like an open source equivalent to Cubase, Pro Tools, that kind of thing. Anyway, we had him on the show, and he works full-time in the project, and he does an amazing job. Ardor is an incredible product. But they're having a donations drive, so they can basically generate some cash to pay him so he can work on Ardor full-time, and they need some donations. So a guy called Andy pinged me and said, would you mind just mentioning this on Floss? They only need about $750 for the rest of this month to break even. So it's really valuable work. Ultimately, I'd like to personally move over to Ardor to use it in my studio. I know Leo's expressed some interest in it. So if you think it's a valuable project, go and pledge $5, $10, $750, whatever you want to do. So
there you go.
You can go to ardor.org to do that.
Very cool.
Well, my friends, thank you so much for another lovely Floss Weekly, and we invite you all to come back next week. We do this show every Wednesday afternoon at 1:30 Pacific, 4:30 Eastern Time. 20:30 UTC at live.twit.tv if you want to watch us do it live. And I shall see you next week, gentlemen, on Floss Weekly.